Discriminants are another thing that comes up during quadratic equations. The discriminant, it's important to know the discriminant is just part of the quadratic formula, but it's the part of the quadratic formula that sits under the square root. So it gives us a lot of important information about whether there will be any solutions, and if so, how many solutions there will be. So when you think about a square root, we know that we can take the square root of a positive number. We can also take the square root of 0, but we can't take the square root of a negative number. So if the discriminant, which is equal to b squared minus 4ac, if the discriminant is greater than 0, so if b squared minus 4ac is greater than 0, there'll be two solutions, because in the quadratic formula, I'm going to scribble it up here, we have plus or minus the square root of b squared minus 4ac. So if that answer there is a positive number, then we're actually adding that number and subtracting it. So it gives us two separate answers. If b squared minus 4ac equals 0, then there'll just be one solution, because this part of the quadratic formula will just be doing plus or minus 0, and adding 0 is the same as subtracting 0. If the discriminant b squared minus 4ac is less than 0, there's going to be no solution, because you can't take the square root of a negative number. So any time the discriminant is less than 0, there'll be no solution. So example 14 here says, use the discriminant to show that the graph of y equals negative 5x squared plus 4x minus 1 has no x-intercepts. So if we were trying to find the x-intercepts, so x-intercept would be let y equal 0. So we'd have 0 equals negative 5x squared plus 4x minus 1. Now, if we're trying to solve that equation, well, solving that equation will give us the x-intercepts, but we're meant to use the discriminant to show there's actually not going to be any. We often use this sort of shorthand, this triangle, to represent the discriminant. So discriminant equals b squared minus 4ac, which in this case is 4 squared minus 4 times negative 5 times negative 1, which is 16. Now this is, well, let's make this positive. Negative 5 times negative 1 is going to give us positive 5. So that's just 5. So minus 4 times 5 is minus 20. So the discriminant is equal to negative 4. That means if we were going to try to solve the equation, we wouldn't actually be able to do it. So since the discriminant is less than 0, there are no solutions to that equation, and therefore no x-intercepts. That graph would not actually cross the x-axis, which is very possible for parabolas. That's a negative parabola, so it must be sitting somewhere, something like this, where the graph doesn't actually come up and touch the x-axis, so it just has no x-intercepts. All right, and last question. This one's another discriminant question, but a little bit trickier. It says, for what values of k will the equation 3x squared plus kx plus 3 equals 0 have one solution, two solutions, or no solution? So let's start by setting up the discriminant. Even though the question doesn't say use the discriminant, if it's a quadratic equation and we're talking about how many solutions it has, the discriminant's the thing that we're going to use. So here we've got a equals 3, b equals k, and c equals 3. And of course our discriminant is b squared minus 4ac, which is k squared minus 4 times 3 times 3, which is k squared minus 4 times 3 is 12, times 3 again is 36. So k squared minus 36. So that's our equation for the discriminant. So if we want the equation to have just one solution, we would want the discriminant to equal 0. In other words, k squared minus 36 needs to equal 0, which means k squared would equal 36, which means k can equal plus or minus 6. So if k equals positive 6 or k equals negative 6, then this equation is going to have one solution. If we want two solutions, we want the discriminant to be greater than 0. So discriminant greater than 0 for two solutions. So that means that k squared k squared minus 36 needs to be greater than 0. And that's a little bit harder than it looks to solve. We can't really just take the 36 over to the other side and take the square root because inequalities with quadratics don't quite work that way. I think a really useful way of solving a quadratic inequality is actually to try to sketch even just a really rough graph. So what I'm going to do here is sketch a graph of the discriminant against k. So k is my value along the x-axis, the discriminant is my value along the y-axis. So if you imagine how you would sketch y equals x squared minus 36, well, this is much the same. This is just sketching a parabola that has moved down 36 units. And this only has to be a rough sketch. Right, like that down there is negative 36. But the key points are these x-intercepts. And we actually just found them because we found that when the discriminant equals 0 is when k is equal to positive or negative 6. Now what that says is if we're looking at the discriminant and we're thinking of the discriminant as being this graph, well, the discriminant is greater than 0 in this part of the graph here. That's where it's positive, but also this part of the graph here. Right, those are the parts of the graph where the discriminant, the y values, are greater than 0. In other words, it's the parts of the graph where it's sitting above the x-axis. So this region here happens when k is bigger than 6. This region here happens if k is less than negative 6. Okay, so in other words, if k is greater than 6 or k is less than negative 6, we will get a positive discriminant and therefore two solutions. And we have to write that as two separate inequalities because it can't be both things at once. It has to be one or the other. For part C of the question, for no solution, we want the discriminant to be less than 0. And therefore k squared minus 36 needs to be negative. And that happens, again, if we go back to our graph, if we're thinking about where is the discriminant less than 0, well, that's happening down here in this part of the graph, in the middle. In between these two x-intercepts, we actually have negative discriminant values because the y values are negative in that region of the graph. And that region of the graph happens when k is in between negative 6 and 6. So that will happen when k is greater than negative 6 and also less than 6. And it has to be both of them because k has to be in between those two numbers. That's a really tricky type of question. Thankfully, sometimes they're calculator allowed. So if it was a calculator allowed question, what we could do is use solve on the CAS, but just set it up with inequalities. So pop this on the screen really quick. If we go action advanced solve, and we can even use k instead of x if we want to, but we could use solve k squared minus 36. So we would still have to set up the discriminant, but we can then solve k squared minus 36 equals 0 for part A. That was one solution. Whoops, no solution. Now that happened, I'm glad I made that mistake because I need to tell the calculator to solve for k. It's trying to solve for x and it's saying, well, there's no x in there. Solve for k, there we go. If we needed for part B the discriminant to be greater than 0, you would just do, I'm going to just hit execute again to copy the equation down. All we would need to change is instead of having an equals 0, we need to use an inequality, and you can find them in Math 3, to put greater than 0. There we go, we get k is less than negative 6 or k is greater than 6, that's what we had before. And again, if I just push execute to copy that down, if we change the greater than to a less than, then we're going to check our answer for part C. And that gives us k is between negative 6 and positive 6. So again, if the question's calculator allowed, you can get the calculator to solve those inequalities, which can save you a little bit of time and effort. Tricky section, lots and lots in for A. It is all stuff you've done before, but that doesn't mean it's easy. So get stuck into it and ask for help whenever you need it.